Hey guys, welcome back. Today we're going to be talking about transformations. So you should have, before you watch this video, copied down the parent functions chart. So parent function means, I always like to say like the OG function. It is the original function that everything else goes around that function. So like for example, y equals x squared. That is the original function for quadratics. It looks like this, right? So these are just basic functions. Every other parabola, so this is called a parabola. Every other parabola is just you changing this one. So what if a parabola looked like this? What if it was upside down? Or what if it moved over here? They are all the original one, this little guy over here, but you just moved it around a little bit. So we're going to look at how we transform those original functions to look like something else. So this is called transformations. There are lots of them, so what I want you to do is kind of draw a line about right there. And there are 1, 2, 3, 4, 5, 6, 7, 8. So we're going to be looking at 8 different types a little bit. So the first one is f of x, and then on the outside plus b. What that means, since the b is outside the function, it means it is moving the y. And this, since it's positive, moves up. Moves up d units. Okay, so outside means y, and then positive means up. The next one would be f of x minus b. And b is just some random number that we don't know what it is. Again, since it is outside, outside of the function, it's y, and this time we're moving down d units since it is negative. So we're moving down. So those are the two y's, up or down, positive or negative. The next one is if the number is inside the function. See how that one is inside? If it's inside, you're going to be moving on the x-axis. And this one is kind of the opposite. So even though it's positive, we're going to be moving left. Move left c units. This one's the opposite. So it's positive, but we're moving left. And last but not least, for this section, f of x minus c is, you guessed it, again, it's inside, which means x, but we're doing the opposite, so we're going to move right c units. We're moving right this time. So that is left, right, up, or down. Are we going to move it left 2? Okay, that means plus 2. Are we going to move it down 2? That means minus 2. And then we'll go ahead and do some other ones. There are some other ones here too. What if the f of x is negative? What if the f of x is negative? Well, that means it's going to be flipped or reflected across the x-axis. So upside down. Flipped upside down. However, what if the negative is inside? That's going to be flipped across the y-axis. Flipped across y-axis. Okay, so that would be more like a symmetry fold, kind of. So the first one would be upside down. Next one would just be like a mirror. And we have two more. What if there is a number on the outside? So it says like 2 or something else on the outside. If it is on the outside, that means a vertical, either a stretch. If A is greater than 1, it would be a stretch, or it would be a compression. If A was smaller than 1. So if A is greater than 1, we'll say A is 2 or 3, then you're stretching it up. Big stretch like goo. And if the number is smaller than 1, like a fraction, like 1/2, that means you're compressing it. You're pushing it down. Okay? Vertically, remember. But if the number is inside, it is a horizontal stretch. Remember, if B is greater than 1, it's a stretch. Or a compression if B is smaller than 1. So this time it's horizontal. So if B is greater than 1, like 2 or 3, you're going to stretch it long ways. So you're pulling something apart long ways. Or if B is smaller than 1, like a fraction again, then you're going to compress it horizontally. So you're going to push it together horizontally like a sandwich. Okay, so that was long, but let's get started for some examples. So the examples are, we're just going to describe the transformation, and sketch the graph. Describe the transformation and sketch the graph. So the first one's part A. Y equals absolute value of x, and then a +2 on the outside. And part B, y equals parenthesis x plus 4 squared. So let's look at these. What is going on here? Remember, for part A, what kind of graph is this? This is an absolute value graph. So we know that is going to be like a V shape, like that, remember? Okay, we also can tell that the number is outside, which means from the chart, that is going to be a Y, which means it's going to move up or down. And since it's positive, since the 2 is positive, we're going to be moving up. So if we have a graph, pretty small graph here, it's okay. This is the original, remember? That's the original. This would be moving 2 up. 2 up. So there's 2. Put your dot here, and we're going to be moving 2 up. It looks exactly the same, except we move it up 2. That's the first one. Let's look at the second one. It's squared, which means that it is a quadratic. And those look like a parabola. So not quite a V, more like a U. This number is inside the parentheses, which means it's moving on the X, so left and right. And it's negative, which means it's moving, remember, inside is the opposite, so it's going to move to the right. So to the right 4. So here's our graph. And the original one looks like this. This one we're going to move to the right 4. 1, 2, 3, 4. Okay? So there's the middle now. Same exact shape. We just moved it over a little bit. Okay. And let's do two more. The stretches and the compressions. Those are kind of hard for me, I think. So C and D. Stretches and the compressions. First one, y equals 4x squared, and y equals absolute value 1/3 x. So first, talk about what type of problems these are. The first one, it's squared, so that's another quadratic. Looks like a U. This number is kind of on the outside of the problem there, which means it's going to be, let's look up at our chart again. The outside is the A1, so that means a vertical stretch. So outside equals vertical stretch. And 4 is greater than 1, so it is, like we said, going to be a stretch. This is really hard for me to just kind of graph on my own. So what I like to do is I just kind of like to make a chart. X, the original, and then what we have here, 4x squared. And I just like to pick some random ones. I usually do -2 to +2. -2 to +2. And I just like to stick those numbers kind of into each one. Remember, this is the parent graph. And the second one is the transformed graph. So let's see what they would look like. The original one, square -2. -2 times -2 is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So now we multiply those numbers by 4 and see what we get. So 4 times 4 is 16. 1 times 4 is 4. 0 times 4 is 0. 1 times 4 is 4. And 4 times 4 again is 16. So let's see if that kind of helps us. Remember, it's going to be a vertical stretch. Here's my thing. I'm just going to go to 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So the original one, remember, kind of looked like this. And let's plot our new points to see what we get. So 0, 0, 1, 4, -1, 4, and then the 16 ones, which we can't do. So it kind of looks like that. A vertical stretch. You're definitely stretching it. And then let's do part D. So this is an absolute value. 1. It is definitely inside this time, which inside means horizontal stretch. Okay, so it's going to be stretching horizontal, so it's going to be longer. 1/3 is less than 1, so actually it's not a stretch at all. It's going to be compressed. So compressed horizontally. And I'm going to make another chart, x. The original is absolute value of x, and then we have 1/3 x. And let's see what we get. So again, I just like to go from -2 to 2. And absolute value just means we take all those things and we make them positive. So make this positive, 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 positive. And now we take 1/3 of those things. So 1/3 of 2/3 of 2 is 2/3, 1/3, 0, 1/3, 2/3. And now we can make our graph. I'm going to go to 1, 2, 1, 2, 1, 2, 1, 2. Remember, the original graph kind of looked like this. Very nice and beautiful. In the original, so -2, and then 2/3. -1, 1/3. Here and here. So see how that is, it's compressed a little bit. It's a little shorter. So that is what those kind of look like. These are probably the ones I'm going to give you more, is which way do you move, left or right? But I wanted you to get a taste of how to do all of them, and hopefully this was helpful to you. But use your chart for help and ask